Position of the camshafts. How does the ECM know which is the event cylinder for a sequentially ejected engine? The camshaft sensor is used to relay the exact position of the camshaft to the ECM for specific cylinder or event information. This includes what stroke the cylinder is on, when to inject the fuel, and when is the optimal time to ignite the air-fuel mixture. Without this detailed information, newer model vehicles wouldn't be able to achieve advantages of lower fuel consumption, emissions, and increased horsepower. The sensor is placed in close proximity to a tone wheel or reluctor, separated by a fixed air gap. Older type sensors are typically analog, producing a sine wave output. This type of sensor has two wires, using a low reference and a signal return. While newer engines now use a digital on-off Hall effect sensor for their increased speed and reliability. This sensor is supplied with a high and low reference, with the sensor returning the signal to the ECM. OEMs may choose to use either a pull-up or pull-down circuit for monitoring the signal output. In this module, we'll be looking at digital cam position sensor voltage high DTCs. To test the camshaft position circuit, turn the ignition off and disconnect the sensor that has logged the fault. Set the digital multimeter to volts, then place the red lead on the high reference terminal and the black to the low reference. Turn the ignition back on. The meter should display between 4.8 and 5.2 volts. Since this is a pull-up circuit, now move the red lead to the signal terminal. 5 volts should be displayed. If all these voltages were correct, the only possible fault would be the camshaft position sensor. But if this wasn't correct, here are the steps needed to successfully diagnose a voltage high DTC. A short to ground in the high reference circuit may cause an ECM fuse to open, setting the voltage high code. To check for this, turn the ignition off and place the red lead on battery positive and the black lead on the high reference terminal. Set the meter to volts and turn the ignition back on. Any reading other than 0 will prove a short to ground in the high reference circuit. Turn the ignition off and disconnect the ECM harness connector. Turn the ignition back on and watch the meter. If voltage is still present, that proves that the short to ground is within this section of harness. But if the meter dropped to 0 when disconnecting the ECM, the short to ground might be in the ECM or a circuit from the ECM. To differentiate, carry out a continuity test between the high reference terminal and all other terminals in the ECM connector. If no fault is found, the short must be within the ECM. With a short to ground ruled out, turn the ignition off and disconnect the affected cam sensor. Place the black meter lead on battery negative and the red lead on the high reference terminal of the harness connector. Turn the ignition on. A meter reading of 0 or substantially lower than 5 volts may indicate an open or excess resistance in the circuit. Move the red meter lead and back probe the high reference terminal in the ECM harness connector. If between 4.8 and 5.2 volts is now seen, this confirms an open or excess resistance in the harness. But if when back probed the meter reading didn't change, the excess resistance or open will be in the ECM. Turn the ignition off and disconnect the ECM harness connector and inspect for terminal tension and corrosion. If no fault is found here, the open or excess resistance must be within the ECM. With the sensor disconnected and ignition on, place the black lead on battery negative and the red on the signal terminal. 5 volts should be displayed. Any substantial increase would be considered a short to voltage. Turn the ignition off and disconnect the ECM harness connector. Turn the ignition back on and observe the meter. If the value remains unchanged, the short has been localized to this section of harness. However, if the meter reading dropped to 0 when the ECM was disconnected, there may be a short to voltage within the ECM or a circuit from the ECM. To differentiate, perform a continuity test between the signal terminal and all other terminals in the ECM connector. If no fault is found, the short of voltage must be within the ECM. With the camshaft position sensor harness disconnected and the ignition switched on, place the red meter lead on the signal terminal and the black on the battery negative. The meter should display 5 volts. If low to 0 volts was seen, move the red lead and back probe the signal terminal in the ECM harness connector. If the correct voltage is now seen, there is excess resistance or an open within the harness. However, if when testing at the ECM the voltage remained unchanged, then the excess resistance or open must be within the ECM or connector. Turn the ignition off and disconnect the ECM harness connector and inspect for corrosion and terminal tension. If this is okay, the open or excess resistance is in the ECM. With the ignition switched on and sensor disconnected, place the red meter lead on battery positive and the black on the low reference terminal. Battery voltage should be displayed. If 0 or substantially less was seen, move the black lead and back probe the low reference terminal in the ECM harness connector. If the correct voltage is now observed, this confirms an open or excess resistance in the harness. However, if when testing at the ECM the voltage was still low, then the fault must be within the ECM or connector. Turn the ignition off and disconnect the ECM harness connector. Check for corrosion and terminal tension. If this is okay, then the excess resistance or open must be within the ECM. Take your time and document all your findings when following these test procedures. This will assist in a successful diagnosis of voltage high DTCs. Thanks for watching. See you soon.